Hello to everyone. My name is Dejan Radic. I come from two companies, Coding Llama and DexStar. In both of them, I'm a CTO. And today we're going to talk about technical challenges of real-world asset tokenization. We're talking about real-world assets. We're talking about things on the ground. And that's why we are on the ground floor. So let's start with today's presentation. In general, at the beginning, we are going to define what real-world assets are. We're going to talk about tokenization, about the challenges that we are facing and that many developers and technical people on projects are facing regarding Oracle's data feeds, multi-chain tokenization, standardization and interoperability, custody and security identity compliance, and at the end, we are going to give a conclusion of the speech. So, what are real-world assets? When we're thinking about things that are on-chain and off-chain, we're usually thinking about the ways how we are going to bridge those differences. And we can define real-world assets as everything that is not on-chain but has value. And we are trying to bring that value on-chain. And when we are thinking about the real-world asset types, we're thinking about financial instruments, so like shares, like bonds, like financial derivatives. We think about commodities like materials, also real estate, intellectual property, and many argue if fiat currencies are actually real-world assets. They exist in the real world and they have value, thus we can conclude that they are also real-world assets. And what we are trying to do is actually to have on-chain representation through tokens, and we want to achieve all the tokenization advantages that are given, which are simplicity, transparency, and the ability to execute things in a way that everybody understands it. So that's why we are trying to do these things. When we think in a way of tokenization, we have off-chain assets and we have on-chain representations. And we see a lot of different things that can be, in fact, tokenized. And by tokenizing them, we have their own, they call it also a digital twin or like representation or abstraction that is placed on chain. So let's start with the first challenge we're facing as developers in this space, and that's the ability to bring data on chain, to have it for the base of calculation of different figures that are needed to represent real-world assets. And when we think about writing data on-chain, we talk about oracles. First, we have an entity. It's a physical entity or legal entity that has a job of actually writing the data on-chain. We have services like this, but when we are choosing these services, we're usually thinking about their authenticity, veracity, and reliability. What do we want to achieve is actual transparency, the straightforward way to write the data on-chain, and we want to avoid the centralization impediments that are being presented either through like the ability to have multiple data sources and actually have a quorum decision based on the data, or to utilize different strategies to actually achieve these issues. And one of the things that usually are aligned with oracles and the issue that we're having is performance or latency issue, because when you issue a transaction to write data on chain, you have some time lag where the things in the real world might be different from the things on chain. Also, lately, we are having a lot of requirements for identity, for like sensitive information that is used as a base of calculation on chain. That's why actually privacy concerns are being raised, and a lot of data that can be written on chain might in fact be the privacy sensitive data. Regarding like alignment of what exists in the real world and what exists in on-chain world, we can say that we have different ways of actually aligning them. And for example, centralized exchanges are using a thing called proof of reserve lately, where they are trying to find the best ways to show that they have certain collaterals or backing for their assets, for the assets that they are holding, in fact. For real-world asset protocols, those are usually auditors or, let's say, institutions that are with their own respective ways that they are trying to actually prove that there are those assets that are existing and that their representation on chain can be trusted. For example, we have different ways of tokenizing and different ways of actually generating yield on the real world and bringing it on chain, and actually having an auditor who would stand behind it and actually present it in the best possible way is something that's needed in this world. When we're thinking about simplicity of usage and bringing the value to more users, we're usually trying to bring those tokens to as much as people as possible. But people tend to have, and still are having, kind of one-chain agnostic view of things, and that's why we are trying to use multi-chain tokenization, or to bring our real-world asset representations on multiple chains in order to tackle wider audience and have also more TVL. But that is also bringing a lot of challenges. One of them is code portability. For example, if you're working only with EVM chains, that doesn't necessarily have to be the problem. But for example, if you're working with other chains and mixing like different kinds of technologies, interoperability is definitely going to be a challenge. And what we are trying to do there, we are trying to bridge the chains, and that also opens additional challenges and impediments that have to be solved. Also, we have like atomicity of execution of transactions, and we have things like managing cross-chain liquidity, which is kind of a business-wise financial issue, which has become actually the issue of a technical nature, because it's not that easy to predict how much of funds and how much of those tokens are needed on which chain and at which point, actually. Nowadays, we can say that in general, we have different kinds of tokens, and we have different ways of representing real-world assets on chain. And we have like evolution of these tokens. Majority of them are based on ERC20, ERC721, ERC 1155, as they say, standards on Ethereum chains. What we are achieving is that we have some kind of standardization that exists on-chain, but also on the other hand, we have a lot of standards that exist for real-world assets in the real world. So what we are trying to do, we are trying to bridge those gaps, and we are trying to connect them in a way that both representations have more alignments. And for just on-chain aspects, we have managed to actually achieve high level of composability by using these standards, and it has enabled us to actually have protocols that are using synthetic assets, that are mixing them in different kinds of ways on-chain and presenting the value to their users. But we still have standards that are off-chain, that are in the real world, that some of them are being built for hundreds of years, and actually bringing them on-chain is kind of a challenge. On the other hand, when we talk about multi-chain interoperability and standardization, we have also the gaps in that area, which are being, let's say, solved by using different kinds of bridging strategies. What we are trying to do with standardization, we are trying to align ourselves with laws and regulations and other standards that exist in the real world. Regarding custody and security as a challenge, there were many talks also yesterday about it, and we have covered a lot of, let's say, solutions in this area. We can actually identify three roles in this context. We have the investor, we have the manager, and we have the custody. When you're managing a real-world asset, you always need somebody who is going to be that bridge. And for investors, you usually have kind of a peer-to-peer system. You have equality. But compliance and also other operational requirements bring us to a position that somebody in this context needs to have more rights and more abilities to influence the system than the others. And those are the managers and custody. Custody has its own, let's say, ways of doing things through key management and solutions like multi-sig, MPC, CMP from like Fireblocks and so on. On the other hand, we have fund managers who are the ones who can decide on different decisions which might be decentralized but also still influence the way how system works. And this is also presenting kind of a technical challenge to tackle that in a way that we are reducing their power and enhancing the decentralization. Because nowadays many protocols in real world assets are using DAOs on one side, but DAO decisions are not, let's say, enforced immediately on chain by straightforward actions, but they are kind of read from chain and then some centralized entity like some fund manager or somebody who founded the product actually needs to execute transaction which would bring that kind of or enforce that kind of behavior. And that's why we are ending in kind of like centralization bottleneck in these ways, which came to the point where we're thinking about ways of solving it, but this is always going to be a cat-mouse type of fight. Regarding security in general, we've seen yesterday also like different talks about audits, and we are trying to overcome these issues the best way we can, actually, by using contemporary strategies of like linting, checking the code, formal verification, and so on. But also, on the other hand, lately we have seen real advancements in monitoring and response, for example, solutions like Tenderly and Forta, enabling us to actually respond to certain actions on-chain and actually do more protection of our on-chain assets than just doing the auditing of the code. Finally, and like last but not the least, technical challenge that we are having is also the one that we are most probably always going to have, especially if we are dealing with real-world assets that aren't financial instruments, but they exist in material. We are using like IoT sensors, and they generate a lot of data. And then if we want to use that as a base of calculation on-chain, we are having a huge bottleneck. For a majority of use cases nowadays in financial means, we can actually solve these issues because bridging these gaps is fine with L2s and all the scalability solutions. But we are demanding more and more, and that's why L2, L3s and solutions that are enabling, that are enabled through parent-child chain, side chain solutions are becoming increasingly important for us. When we talk about performance, we usually, for smart contracts, think about gas costs. We can call it a performance category, because actually gas consumption in a smart contract in real-world categorization of code execution would be, let's say, something that consumes time, but on-chain it costs money. When we talk about multi-chain execution, we also are opening a lot of questions regarding scalability, especially if we want to have like this atomicity moment of executing a transaction on multiple chains to have it fully atomically executed. And lately we are seeing like solutions, and they have existed even before, like which are kind of managing the peaks of requirements for transaction execution, usually happening like in the bull markets where you have high demand towards transaction execution, and we see chains actually preparing for that by utilizing different strategies in this context. So, since this talk was most about challenges and it has opened more questions than it has closed, when we talk about like engineering challenges and interesting problems, we need foundational skills in order to solve them. But people tend to say that actually defining a problem is half of solution. And when engineers think about these solutions, it boils down to a couple of questions. And those questions are usually ones that are asked by product managers. And those are like, is it accessible? Is it fast? Can we do it simply? Is there a way to actually simplify these things? Is it a known solution? Because sometimes bringing something new might be a good thing, but also like we don't know what the obstacle was, what the challenges are. And regarding custody and like having third parties with more influence, who can do what? So like for everybody to be clear that there are roles that have different kinds of access rights in the system. And the bottom line question in general is, does it work? For engineers, it's usually about working. For product management, it's about bringing value. But if it doesn't work, it doesn't bring value. So bottom line question is, can we actually make the thing work in a way that's needed to, and to tackle all the challenges that are coming in the future in this area? I think that's it.